Hi guys, Mr. Specht here. Just wanted to have some encouraging words for the algebra folks, 8th graders. I know I sent you a video yesterday, or today sent you the video, working problems out. I'm going to do it again today and send that to you. Keep working hard. I know it's not the same for us being in class, but still get the information and ask questions. I'd love for it if you would ask me a question, maybe through email. Mr. Specht, problem number 5, I wasn't sure how to do, and then what I can do is show you on the next video. I could show you how to do number 5 or whatever. We could do that. And that way you're keeping up, and I want you guys ready for high school. Even if we're not together, I still want to get you guys ready for high school. So, all right, keep up the good work. So tonight again, we're going to do section 10.4, which is radical equations. So if you like solving equations, I think you guys are really going to pick up on this pretty well. The idea basically is to do the opposite of a radical. The opposite of a radical, or taking the square root of something, the opposite is squaring it. Okay? All right, folks. So we are in section 10.4, solving radical expressions. This is on page 636. Okay? So if you want to follow along with me, go ahead and open up your book, page 636, and it'll almost be like we're in class together. You'll hear my voice, but we're just not getting to see my beautiful face the whole time, and see my beautiful active board, and my beautiful drawings or whatever else might be on there. But you're getting to see the textbook, and hopefully you're still learning algebra. So that's the main idea here, okay? All right, so solving radical expressions, again, radical equations. Again, an equation, of course, is where you're going to solve for the variable, and it has a radical in it. To get rid of the square root of something, you square it. So in this case, we're going to be squaring both sides, because remember, if you do one thing to one side of the equation, you got to do the same thing to the other side of the equation. So if we square one side, we got to square the other side. So that's what's going to happen here. So I'm just going to move my book around here. Let's take a look at problem 1 here, the example problem, and we'll just zoom in just a little bit so you can see it, and I'll follow along with my finger here, and I'm hoping that this will get you in a good place here. So here's an example of a radical equation. It has a radical here, plus 7 equals 16. And so you subtract 7 from both sides. And so you're left with the square root of x equals 9. Okay, again, they don't do a very good job of showing the work. Remember, I want you to show your work showing that you're subtracting 7 from both sides. And then you have this. Well, to get rid of that radical, again, the opposite of squaring something is to take this, or the opposite of square root is to square it. Sorry. So you square both sides, and then x equals 81. Okay, then they put 81 back in to check it. You always want to check your work, all right? And you can always guarantee that you'll get it correct if you put that value back in and see if it works, okay? So they do that. The square root of 81 is 9. 9 plus 7 is 16, okay? So here on the got it example problem there, the got it one, remember you would add 5 to both sides. So you'd have the square root of x equals, and then when you add 5 over here, you get positive 3. You square both sides, so x equals 9. Okay, and then you put it back in and check, and so on. Okay, remember, I'll give you some problems to practice, and if you have questions, feel free to email me those, and so on and so forth. And if you want your email address included in my main emails, just email Mr. Memmer, or have your parents email Mr. Memmer to put that on Sycamore, your email address on Sycamore, so we can get those included. Okay? All right, well, I'm going to turn the page, and zoom out just a second here. So now we're over on page 634, and again, we zoom out just a little bit. At the top of the page there, up here, it goes through another problem using a radical equation, same idea, okay? Down here at the bottom, problem 3. Let's zoom in on problem 3 just a little bit here, and move my book over. There we go. It says solving with radical expressions on both sides. So now we have radicals on both sides of the equations. So what do you think we're going to do? We're going to square both sides, and that's what they do here in the second step, is they square both sides. And the square root, or the radical, cancels, because the opposite of a radical is squaring. So they basically, the radical just drops out once you square it. So you're left with what was inside the radical, 5t minus 11 equals t plus 5, which was on the inside here. It looks like they add 11. Wait, is that what they do? No, they subtract t from both sides. That's where they get the 4t. Minus 11 equals 5. And then they add 11 to both sides. So it gives them 4t equals 16. Then they divide by 4, t equals 4. Then they want to check your solution. So you go back to the original, which is right there, and you put the value of 4 in. So 5 times 4 minus 11 under the radical equals, does that equal 4, the square root of 4 plus 5? And they get square root of 9 equals square root of 9, and that is true. So you get that. So again, what would be the first step here? Let me give you a second to think about that. The first step would be to square both sides. That's right. You square both sides and then solve your equation. Okay? Pretty easy, right? Well, we'll see. There's not much more to it, to be honest with you. There's one more type of problem. It's very similar to where you might be doing some factoring as well. But we're going to try to find some extraneous solutions. Remember, extraneous means that that solution is not a real solution. Okay? So look over now at the next page, page 635. Let me back out, and then let's move over. It's page 635 right here. And then we're looking at problem number 4 at the top of the page there. And here's problem number 4. It says identifying extraneous solutions. It says right here, an extraneous solution is an apparent solution that does not satisfy the original equation. Always substitute each apparent solution into the original equation to check for extraneous solutions. In other words, check your work, okay? Put your values back in. So sometimes you get 2 solutions, and so you got to check them both, all right? So let's just go through problem 4, and then I've worked out a few that I want to show you real quick, okay? I don't want this video to last forever. So in problem number 4, it says n equals the square root of n plus, or the square root, of n plus 12. So they do that. So what's the first step to get rid of the radical? Square both sides. So again, you square both sides right here. You get n squared equals n plus 12. Again, what happens when you square the radical? The radical just cancels out. Okay? Then they're going to subtract n and subtract 12 from both sides. So now we look at this. We have a polynomial. So we know when we have a trinomial like that, we're going to try to factor it. And that's what they do. So remember, you just make a t-chart. You can make a t-chart over here. And you see that negative 4 times 3 gives you negative 12. And when you add negative 4 plus 3 gives you negative 1. Okay? Then they factor it. And you get n minus 4 times n plus 3 equals 0. You set them both equal to 0. And so you get n equals 4 or n equals negative 3. The last step, again, is to check your work. So put the values of both of those back in. So you put 4 in for n, and 4 plus 12 is 16, and the square root of 16 is 4. So 4 does equal 4. Over here, you put negative 3 in. Negative 3 plus 12 is 9. And the square root of 9 is 3, that does not give you negative 3. So that one is a big no-no. That is an extraneous solution. So the only solution then is 4. Okay, so just be careful on those types. Okay, so last but not least, what we're going to do is go over to the problems. The assignment for today is on your homework sheet. Again, here's the homework sheet that I sent out. You're going to watch my video. And then you're going to complete page 636, which is what we're getting ready to turn to, 7 through 37 odds. And again, the reason why I'm giving odds is so that you can check your answers in the back of the book. Not so you can cheat, but just because we can't be together every day, I want you to have some way to make sure that you know what you're doing. So if you're missing all these, you need to email me. Mr. Best, I am just having a mess with this, and we can get you figured out here, okay? Because I want you to do that before you take the quiz, because again, on Thursday, you're going to be taking a quiz. I'll send that quiz to you. All right, okay. So on page 636, which is right here, let's zoom in a little bit just for a second. And number 14, I've worked out for you, which is right here. It says the square root of 10b plus 6 equals 6. So I've worked that out here on my notebook, and I'm just going to show you that right now, okay? This will be just like the other ones that we've done here, okay? And I'll just walk through real quick. All right. So again, that's what we started with, 10b plus 6. The square root of that equals 6. So again, the first step to get rid of the radical, you square both sides. So 10b plus 6 equals 36 because 6 squared is 36. Subtract 6 from both sides, so you get 10b equals 30. Divide by 10, b equals 3. So I'm just going to check it. So I put 3 in where the b was. 10 times 3 is 30. 30 plus 6 is 36. So the square root of 36 does equal 6, so it checks out. So again, that's number 14. So therefore, the ones around it, like 13 and so on, can be very similar to that, okay? All right. There's another one that's very similar to that would be number 24. And you can't see it. So there we go. Here's number 24. Number 24 has a radical on both sides. We looked at an example with that. The first step being square both sides when you have square roots. Okay, so we're squaring both sides in this step right here. I'm left with 3m plus 1 equals 7m minus 9. Here I'm showing that I'm subtracting 7m from both sides. So over here I get negative 4m plus 1 equals negative 9. Then I subtract 1 from both sides, and I get negative 4m equals negative 10. I divide both sides by negative 4. I'm left with, because a negative divided by negative is a positive, I'm left with 5 divided by 2, or 5 over 2, which is the same thing as 2.5. Either answer, of course, would be correct for me. Okay? Again, questions, email me. All right, and then I have one more. This is probably the most complicated of the three, or of all of them, and it's just one with an extraneous solution, which you're going to be able to do. Okay? So I took number 32, which you'll see, it's on page 637, here's the original. N equals 4n plus 5. Again, to get rid of this radical, you square both sides. Square both sides. So you do that, you're left with n squared equals 4n plus 5. I subtract 4n and I subtract 5 and move those to the left side. So I have this equals 0. Okay, because on the right side, I'm going to be left with 0 once I subtract both of those. Okay, then I have this. So now I have a trinomial, and I want to try to factor that. So I need two things that multiply to give me negative 5, but when I add them, gives me negative 4 because of my negative 4 and my negative 5 right there. Well, it just so happens it's negative 5 times 1 and negative 5 plus 1. So I substitute in here n minus 5 and n plus 1 for my negative 5 and my positive 1. Therefore, here n must be 5 because 5 minus 5 is 0. And here n must be negative 1 because negative 1 plus 1 give you 0. Okay? Last step from there is to test both solutions. So you just put those values in. So I put 5 in for n. I put it in here, and I also put it in over here. I work that out. I get 5 equals the square root of 25. And the square root of 25 is 5. So 5 does equal 5. That checks. Okay? Right here, I put in negative 1. I put a negative 1 here. 4 times negative 1 is negative 4. And negative 4 plus 5 gives me positive 1. And the square root of 1 is 1, not negative 1. Therefore, it's an extraneous solution. So only negative 5 is a solution. Okay? All right. Well, this video has already gone over what I wanted it to do. I don't want to make you watch a million minutes of video. But again, since we can't be in class, I just want you to do well. And I want you to be ready for high school. And please ask any questions. If your parents have any questions, let me know. And we'll just keep trucking on. Okay? Stay safe. God is in control. Don't worry about things. Just let God do his work. Stay faithful. And stay in prayer. And remember, I love you guys. All right? We'll see you later. Bye.